For the past 5 or 6 years, we have been slowly converting most of our home lighting to LED lamps, replacing either incandescent bulbs or the dreaded so-called curly bulb. The curly bulb, or compact fluorescent lamp, CFL, is one of a very short list of things in this life that I actually hate, so I won't say much about them lest my prejudice shows. They are much more energy efficient and operate much cooler than the incandescent bulbs they replace. Incandescent bulbs are the traditional light bulbs that evolved from Thomas Edison's patented model way back in 1879. The improvements to Edison's originals, such as tungsten filaments instead of carbon and the use of inert gas inside the bulb itself, happened over the years and made the devices more practical and longer lasting. An incandescent bulb works by heating a wire filament until it glows and produces light. The filament is typically made of tungsten these days, as I said, because of its high melting point. When an electric current passes through the filament, it heats up to a temperature that produces light, a secondary output. The glass enclosure, or bulb, is a vacuum free of oxygen. Oxygen would allow the filament to rather quickly disintegrate. Sometimes the enclosure is filled with an inert gas like nitrogen or argon. LEDs are a solid-state device like a transistor, a light-emitting diode to be specific. When configured to work as a light bulb replacement, LEDs are much more efficient than traditional bulbs or even curly bulbs. They can convert close to 100% of the energy they use into light, whereas an incandescent bulb might convert 10% of the energy applied to it as light, the rest being lost as heat. If you don't have any LED replacement bulbs around the house and are looking to pick some up, here are a few things to be aware of. LEDs do produce heat, and excessive heat can and will shorten our life. If you're going to be using an LED in a confined space or closed housing, make sure to buy one that is suitable for that application. It will handle the heat better and last longer. Similarly, if you're using one in an outdoor application, get one with an outdoor rating, one that can handle a damp environment and extremes of temperature. The number one and two things you'll probably be concerned with are the color temperature and the light output. The color temperature, measured in degrees Kelvin, sounds confusing at first, but it's really just a number that lets you know what the light from the bulb will actually look like. Often the big box stores will have some kind of display to let you compare the color temperature and the appearance. They may give names like soft white and cool white, but it might be more helpful to stick with the color temperature rating as a guide. Generally, anything below a color temperature of 3000 should look a lot like an incandescent bulb. Higher values look bluer, more like daylight. Of course, a more daylight looking light may be what you're after, so now you know how to find those. The scale can initially be confusing since lights with a, quote, warmer appearance have a lower color temperature. The light output is generally measured in lumens. For reference, 800 lumens is a similar amount of light to that produced by a 60-watt traditional lamp. Often LED bulb packages in the US will say something like 100-watt equivalent or similar. I'd like to be clear that the power consumption equivalent is only a guide. An LED lamp of similar brightness might only use 17 or 18 actual watts. Something else you might want to look at is the ability of the light to faithfully reproduce colors, particularly if you're using the light for specific tasks that demand some kind of color fidelity. This takes a bit of engineering since the typical LED output is a bluish white color, and the bulbs use a phosphor coating to produce the light that you actually see. The Color Rendering Index, or CRI, can help with this. Essentially, the higher the percentage, the more true the colors should appear using that lamp. Anything with a CRI above 90 degrees should give you a good color fidelity if you need that. Lastly, AC power provides alternating current with a frequency of 50 or 60 Hz, depending on which country you live in. Lights connected to AC will tend to flicker at that frequency. Some people are more sensitive to this than others, and the majority of us simply don't register it. With incandescent lamps, this variation also happens so fast that the filament in the bulb effectively does not stop shining between cycles. It simply doesn't cool down enough in that split second. With CFLs and LEDs though, the lamps can actually turn on and off many times a second, which can irritate some people. Try to imagine a 60 Hz hum that you sometimes get with poorly shielded audio, but with light. Yuck. Typically, more expensive lamps will be less prone to this, as they can incorporate circuitry to minimize the flicker. In the USA, regulations effectively ended the sale of incandescent bulbs for general use as of August 2023. Some kinds of lighting, like Christmas decorations and candelabra lights, are not affected, but the normal household type bulbs are now persona non grata. So, going forward, you'll likely be picking up LED bulbs from the hardware store, and now you hopefully have a better idea of what to look for. Hey, thanks for watching, and check out the links in the video description below.